Hello everyone. In this video, I will demonstrate how to do simple line graphs using R. So let's get started. I will be working on two data sets. One is called hiccups and other one is called text messages. So let's open the hiccups first. So here you are measuring number of hiccups a patient had in a minute. Okay, and the idea here is, we will give them some intervention, which is, different types of medical treatment. Baseline is no intervention given at all. We just counted number of hiccups per minute, and after that we have given them treatment called, maybe something related to tongue wagging, something related to carotid, and then something related to rectum. So the way it works is, first count the number of hiccups per minute, don't give them any treatment, then wait for 5 minutes, and then give them first treatment and count number of hiccups per minute they had, and then wait for 5 minutes and then give the second treatment, count number of hiccups per minute, and then again wait for 5 minutes and you know give the third treatment and count the number of hiccups per minute. And this for every patient, the intervention order uh, was random. So first one might be given first tongue, then carotid, and then rectum, while the second patient might be given carotid first, rectum second, and tongue third. So it's all random. So this is the data set we have, and we want to do a simple line plot that will show me the mean number of hiccups per minute by hiccups type. Okay, so I guess this should be called intervention. This should be called hiccups. Okay, so I just wanted to make sure I get it right. So let's go ahead and use this one. So I created a folder on my desktop called R project, and in our project I have a folder called data sets, where I'm storing all my data files. So you can see it here, desktop, R project, data sets, and that's where I have my hiccups and text messages. So this is set as my working directory, and I will first load the ggplot2. This is the package we will be using to plot our line graphs. And I already have that. All I will be doing here is updating my package. I don't want to restart R. So it will go ahead and upload my package. And once you install the package, you have to load it and bring it to the library so that we have all the functionalities available. So I will do command enter here. I'm working on my Mac. Then I will set the working directory to my data sets folder, and then this will simply retrieve the current working directory here. Let's read the file. This is the text CSV file, hiccups, and I'm reading that file. And I want to show first 10 records. So these are the first 10 records here. So we have hiccups and intervention there. Let's go ahead and do the basic plot here. This is very similar to the bar chart for means that we did earlier, but let's go ahead and do that. So my line graph, just say my line graph, and then first we will define the object for my ggplot. So I will pass reference to my line data and define aesthetics in terms of x and y variables. So on x axis I want to show um, intervention, and it has to match the spelling and the case. Okay, it's very case sensitive. So, and then on the y-axis I want to show hiccups. Okay, so this again, it has to be case sensitive. Okay, and if I want to append multiple layers, I have to put plus here. I cannot do it on second line. Okay, this basically defines the ggplot object. And all I'm doing here is passing the reference to my data set and defining what I want to plot on X and Y axis. Okay, but if we haven't put any geometric element on it right now, so let's go ahead and put the second layer. And this time we want to plot the mean hiccup, so we have to use a function called stat underscore summary. Okay, and we have to say function equals mean. That's what I want to plot. And geom that I want to use here is simply point, so we want to show the point here. Okay, and I want to give a like heading to my chart and axis. So let's give a title. So let's call labs, and I will say title equals mean hiccups by intervention type. Okay, and then on the X I want to show, let's say, intervention type, and on Y I want to show mean number of hiccups per minute. Okay, so let's call it hiccups, and that should do the trick. Let's plot our chart by invoking our line graph here. So I will bring my cursor here, press command and enter on the Mac. Alternatively, you can run from here as well. And then I will run the second command that will plot the points. So we just plotted the points with that showing me number of hiccups per minute by different types of intervention. Okay. Now let's move on. What I want to do is I want to connect this dot by a line, and I want to set the color of the line to be red and the line type should be dashed. So I will copy this one. All we will be doing here is we will be adding one more layer, okay, on the top of existing layers. So let's add another layer here called stat underscore summary. We again will be using mean. Okay, and then we have to use geom equals line, and this is where the distinction is, where to define the aesthetic properties here and sort of indicate how many groups we have. So here we just have one group, so we don't have different types of group for different types of intervention. So here we have to specify uh, AES, I will say group equals 1, because this is how it will connect all the dots. Okay, so let's do plus here. Let's run this one. So you see all the dots are being connected by a line. We need to specify the color of the line to be red. So I will say color, let's do it on second line. Color equals red, and line type equals dashed. Okay, so you can see that we connected the dots by dashed line and the color is red. Moving on, we have to show the error bars for every data point here, and the line color of the error bar should be orange with width of 0.1. So let's copy this one, and again all we will be doing here is adding another layer on the top of existing layers. So here let's add another layer. I would say stat underscore summary, and we will use function dot data equals uh, let's say that will be equals to mean confidence interval based on normality assumption. Okay, normal, and then we have to use geom function equals, let's say, error bar, and let's see what this one does. Okay, so you see it's showing the error bar. The error bars are pretty big. We need to decrease the width of these bars, and we need to set the line color to orange. And so let's do that here. Color, let's use width equals 0.1, color equals orange. Okay, so after I ran this commands, I see that error bars line color is orange and the width is narrower now, so looking better. So this is how you should do that. Let's do, so if you remember here, we use group equals 1 because we just had, you know, 4 different labels of intervention type, and we have score for each intervention type. But sometimes you have not just intervention type, but you have another independent categorical variable which you can use for grouping. For example, here text messages .csv. Let's open that data set here. So here you see we have experimental group. So let me explain this data set. So here what we are doing here is we are sort of doing pre-test and post-test, and we are sort of evaluating the performance of on a grammatical test. So these are the performance evaluation scores on grammatical test. So we have basically pre-test, which is the baseline, and we took the test again after the 6 months. Okay, and sort of noted down the score. Now for each timeline, like you have experimental groups, so we have kids, like this data is for the children, so children who were encouraged to send text messages. Okay, uh, their pre test was recorded as a baseline, and after 6 months as well their score was recorded, and these were compared with the control group where the kids were not allowed to do any texting using phone and wanted to see the effect of that on our grammatical test scores. So this is the data set we have, and what we really want to do here is, you know, so we have to plot the grammatical score by line type, but so because we have baseline and after 6 months, but while doing so for the timeline, we for each type of time we have like baseline and after 6 months there is a control group and text messages, so we have to group the data by that. This is simple explanation of the data set here. So let's go ahead and dive in. So here I want to plot the mean percent score on grammatical test by intervention type and groups. I would say and time. Okay, so plot separate line connecting dots for experimental groups. Okay, or you know, okay, so we'll see that we want to show the error bar. We don't want to show any colors as of now. So let's read the data set and show the things here. So we have experimental group, we have time. Okay, so let's say let's be consistent. So I would say by experimental group and time. Okay, so what I can do here is it's very similar to my last code, so I will just copy this one and make some changes here. Okay, this will save me some time. So I'm gonna paste it here. Now you have to be careful when you copy and paste. You need to understand what changes you need to make. Okay, so here first of all data set is different, so I will use _2. This is what I named it here. Okay, and then we will have time on the x-axis, and then here we'll have grammar _score. Okay, now as I said earlier, it is very case sensitive. Okay, so you have to type exactly as is. If you use the lowercase, all lowercase, this will not work. Okay, so for example here, if I type in time, this will not work. Okay, so let's say time here. Okay, and I want to plot the points. uh, so here I want to take out the color because this will overwrite anything that I will mention up top. So let's not do that right now. And I want to do the same here, just strip all the formatting done there. So here I want to say this is mean. Let's say the title of the chart is mean grammatical score, and on x-axis we have time, y-axis we have, let's say, mean grammatical score. Okay, so let's run this much. Okay, let's see whether I'm getting any data points. Okay, so right now we just got the bare minimum. We have baseline and 6 months, pre-test and post-test. We are ignoring the third dimension, which is the experimental group. So this is in general, but we, as you know, that we conducted the pre-test and the post-test for our control group, which is baseline, as well as text messages. Okay, that's the second group. Okay, so what we will do here is, I would say, we use color to our advantage here, and this what we call here experimental group. So we'll say experimental group. Okay, so let's just do this much. So I guess this is case sensitive, so experimental group. Okay, so now you see, it's plotting two different points. Okay, and but when it comes to the line, so this is working fine. We are seeing 4 dots. Okay, and we are seeing 4 error bars, but what is messed up is a line here. It's just showing me one line connecting the overall mean for baseline and 6 months. We have to tell that don't treat as group one, only one group, but treat it equal to the experimental group, and that should do the trick. Okay, so now this is what we get here. Again, error bars, it's always good to set the width. So width equals 0.1. Okay, let's run it, command enter, width here. So this is looking better. Okay, now this underscore, I want to get rid of it in the legend title there. So I would say here's color equals, let's say, experimental group. Okay, and that should do the trick. Okay, so this looks better now. So this is how you would sort of create separate lines for different groups, and this is very much sort of needed when you're doing statistical analysis like ANOVA. Okay, so here basically we can see that there wasn't much difference between the experimental group and baseline group in the pre-test, but in the post-test, looks like the text messengers, the kids who used to who were allowed to send, who were encouraged to send text messages over the period of 6 months, they did not perform that well when it comes to grammatical test, but the control group, they perform better. So this is how you would interpret the data. Last thing is, if you want to save the file, default size is like, let's invoke gg save and give a file name, and it will save a default size of 8.4 by 5.2 inches image, you can define different size here. It's 5 by 5 image here, and if you go back to your folder, okay, so go back to data set here, png1 here. Again, you can save it in a different format as well, like JPG or JPEG format as well. There are a lot of other formats that you can Google. This is the default size, and this is the like 5 by 5, not looking that good, but just wanted to demonstrate this. You can just copy and paste in your Word document when you're doing any sort of documentation for your work. So this is all I had in this video. Thank you very much for watching.